So when I read this problem where I want to find points where the graph has horizontal and vertical tangent lines, of course I know tangent line is requiring that I find slope, or I find the derivative. So the first thing is I freak out when I look at that equation because I say, look at all the x's and y's, and I know that I can't get y by itself because there's two different versions of it, a y squared and a y, and I certainly can't isolate one of them. So I'm going to take the derivative implicitly. And, whoops, I didn't mean with respect to y, I meant with respect to x. So for the first term, I would get power down, I'd have 8x, and then I could put a dx there, but I don't really need it because that equals 1, so I'm just going to erase it. Plus, then on the next one, I'll power down, but this one is a dy dx because I'm taking the derivative of y this time, and there ain't no x in that piece. Next term is just negative 8, because I'd be powering down just like normal. Next piece is 4 dy dx. Here's y. Get it, y? Just kidding. Because I'm powering down, so 1 times 4 is 4, and then I'd have y to the 0 times dy dx. So that's why that y to the 0 just disappears. And then the constant will be plus 0. I can write it in or not write it in. And the constant on the other side will be just 0. So now I need to get the dy dx's by themselves. So it's a dy dx party. Everybody else not invited. So I'm going to move the other terms to the other side. So hopefully you agree with that. And then I'm going to factor out dy dx. And then I'll get dy dx by itself by dividing by that parentheses on both sides. And I'll see if I can reduce it. I think I can factor. So there, I did all that work and found the slope of the tangent. Now, I want to know when this slope is either a vertical or a horizontal tangent line. And so I have to remember what that means in terms of the slope itself. So if I have a horizontal tangent line, let's see, that means that, first I'm looking at a rational polynomial function, and in order for it to be horizontal, the slope would have to be 0, which means the numerator would have to be 0. So I'm going to set the numerator equal to 0. So I've taken the numerator of my rational polynomial slope, and I've set it equal to 0 because that's the only way that slope can equal 0 is if the numerator is 0. And when I solve, I'm going to get x equals 1. Now, it wants to know the points. So I know the x value of the point. How do I get the y value? Well, hopefully you said plug it back into the original, which is correct because the only way I can get y values is from the original function. So I'm going to plug it back in. So I plugged it back in, and of course that gave me a crazy quadratic. And I solved that quadratic all the way down, so make sure you can follow all the steps. Remember, here's where you need to pause and think through, maybe do some of it yourself. And then of course I get two answers for y, because it is a quadratic. And remember, my x value was 1, so I can write my points with x comma y, and then the other x comma y. So there's, two locations on the graph where I have a horizontal tangent. Now I'm going to have to find the vertical tangent. But remember, in order to be a vertical tangent, the slope must be undefined. And the slope will be undefined when y equals -2, because the denominator would have to be 0. And so repeating that entire process, now that I know the y value for the vertical tangents, I'll plug it back into the original to get the x values. And again, I get a quadratic, so it'll generate two answers, and then I write them as ordered pairs. Again, pause the video so you understand.